Okay, this PowerPoint I refer to as the Chapter 1 summary activity. It runs through a series of what-ifs with a problem that has to do with grade averages or test grades for a particular class. All right, so consider the following test grades for a statistics class of 20 students. And it lists them out. First thing it's asking us to do, calculate the mean and standard deviation for this class, round to 2 decimal places. So you're never going to be expected to do any type of mean median calculation with a list like this. You want to go to L1 in your calculator, sort the list if you need to or feel you need to. Do your one variable statistics. From the one variable statistics, you identify the mean and the standard deviation. The other things they're asking us to do with it, interpret the standard deviation in the context of this problem, and is it appropriate to describe the center and the spread of this data with the mean and standard deviation. Okay, so after you get that data into your calculator, run your one variable statistics, you should get the mean to be 84 and the standard deviation to be 6.42. Interpreting the standard deviation is a pretty common free response question. The wording you should use for this question should look something similar to this. The student's grades typically vary from the mean of 84 points by about 6.42 points. You want to have the context. It's the student's grade here. Typically vary from the mean. That typically varied for the mean is always going to be there. Of, state what the mean is with its units, by about, and then the number with the units. You always want an about, an approximately, something to indicate that this is an estimation. That number is not an absolute. Okay, is it appropriate to describe the center and the spread of this data with the mean and standard deviation? As a reminder, the two options you have to describe the mean and the center and the spread, you can do mean with standard deviation, or you can do median with IQR. They have to pair up like that. So the mean and standard deviation are appropriate because the data is reasonably symmetric and it has no outliers as shown in the plots below. If the data was strongly skewed and or contained outliers, the appropriate measures to use would be the median and IQR. So in a free response question, if you are going to state that your data is reasonably symmetric, you need a graph in order to back that up. You can't just say it's reasonably symmetric unless you were given a graph or you create one yourself. So the easiest graphs to create, if you're going to draw it just by hand, dot plots are usually pretty quick to do. You most likely already have the data in your calculator if you calculated the mean and standard deviation. So you can quickly construct a box plot either by looking at the graph that you created or by the 5-number summary at the end of your one variable statistics. So neither of these graphs show strong skewness nor outliers. It's appropriate to use mean and standard deviation. All right, so this is the original list of 20 students, the grades of the 20 students. Suppose there was one student absent and takes the test the next day. What if the student scores an 84? What effect would that have on the mean and standard deviation of the distribution? So we already calculated the original mean, the original standard deviation. Now what we're going to do is add in one more score of 84. So you already have this in L1 in your calculator. So go back to L1, add an additional 84 at the end of your list, and then rerun your one variable statistics. Okay, we get a new mean of 84 and a new standard deviation of 6.26. Now here is the deal. If the mean was 84 and we include one more data point that's equal to the mean stays at 84. That's not going to change. Now the standard deviation is going to become less. The standard deviation is the measure of spread around the mean. you put a number in that has no deviation from the mean, it's going to cause less spread. It's going to cause that standard deviation to decrease. So the new score is exactly equal to the mean. Therefore, the mean will not change. Score equal to the mean has a deviation of 0. Therefore, less deviation, meaning lower standard deviation. Okay, so we're back to the original list of 20. The what if here, what if that one student that's absent scores a 95? What effect does that have on the mean and the standard deviation? So go back to your list, delete out the 84 from the last what if, replace that with a 95, rerun your one variable statistics. The new mean is 84.52. The new standard deviation is 6.7. The new score is greater than the mean, therefore the mean will increase. That's common sense. If you're in a class and your average for the marking period is an 84, and you take a test and you get a 95, if you did better than your average, it's going to increase your grade. Now, as far as standard deviation goes, the new score is more than one standard deviation from the mean, therefore the standard deviation increases. So if you're more than one standard deviation from the mean, you've increased the variation of the data. So the standard deviation is going to go up a little bit. Okay, next what if. This is the original group of 20. We got the one student that's absent that's taking a test. That student scores a 79. What effect is this going to have? So in terms of calculator keystroke skills, go to your list, remove the what if from part B, put in a 79, rerun your one variable statistics, and you should get your 83.76, 6.36. So does this make sense? The new score is less than the mean, so the mean will decrease. If you have an average of 84 and then you get a 79 in your next test, your average is going down. Now, as far as the standard deviation goes, that 79 is less than one standard deviation from the mean. Therefore, the standard deviation decreases. So the average was 84. 79 is 5 points less than the average. The standard deviation is 6.42. So you're less than one standard deviation away from the mean. That causes less deviation, causes the standard deviation to decrease. Okay, our original set of 20. Next, what if that 21st student takes the test and gets a 15? Now, 15 on the surface would appear to be an outlier. It's a number that's much smaller than the typical data point in here. So there's a really good chance that we're not going to want to use the mean and standard deviation anymore. We're probably going to want to go to the median and the IQR. So in this particular set of questions, it's asking you to calculate the median and IQR for the original set of scores. So go back to your list that had the what if in it from the part C. Get rid of that. Rerun your one variable statistics. Identify the median. And in IQR, you can't get directly. You got to subtract Q3 minus Q1, and that will give you the IQR. Okay, go back to your L1, put in a 15, calculate the new median, new IQR. And then they're also asking us to confirm that that is an outlier, and we'll get to that in a moment. So the original median, the original IQR, new median, new IQR. Okay, confirm that 15 is an outlier for this data set. So we're going to be using the 1.5 IQR rule. The 1.5 IQR rule, unless you're told otherwise, is what you're going to use to classify something as an outlier or not. So whatever the IQR number is, in this case, 9.5, we're going to multiply that by 1.5. That gives us 14.25. We're going to subtract that number that we get from Q1. Any number smaller than that is an outlier. Since 15 is less than 64.75, it is an outlier. Now, if we were checking an outlier on a high end, we would take that 14.25, add it to Q3, and that would give us what's known as the upper fence. Any number bigger than that would be an outlier in the high end. We don't really have to worry about that for this particular question. Also, something that we didn't have to worry about for this question, but it's worthy of review. This is pretty much acting as a Chapter 1 review, that if you're asked to interpret the IQR, it's the range of the middle half of the scores is approximately 8.5 points. So, by AP rubric, you're going to have to put it in context. I'm sorry, don't want to focus on that first. The range of the middle half of, that's always going to be there for the interpretation. Then the context. Scores always have to have approximately with a label. That puts it in context at the end. All right, we're continuing with the what if of that 15. Calculate the mean and standard deviation for the data, including the grade of 15. Compare these to the mean and standard deviation of the original 20 scores. So we already have the original mean, the original standard deviation from the original set of calculations we did. Okay, you should still have that 15 in your L1 in your calculator. If you've already lost that one variable statistics set of data because you were doing the 1.5 IQR calculations, rerun your one variable statistics. Okay, what do you observe from the above results? Does this make sense? We're going to address this on the next slide. So we are dealing with the what if of that student taking the exam who gets a 15 on it. So the original median was 84.5. The new median is 84. The original IQR was 8.5. New IQR is 9.5. So that changed by about a half a point. That changed by 1 point. The original mean, 84. Original standard deviation, 6.42. New mean, about 80.7. That went down through 3 points-ish. This one here, the standard deviation changed by about 10 points. So let's summarize all this based on stuff we've learned in Chapter 1. The mean and median both decreased. This makes sense because the value of 15 is less than both the mean and the median of the original set of grades. IQR and standard deviation both increased. Both the IQR and the standard deviations are measures of the spread or variation in the data. Since the score of 15 is much less than the rest of the scores, this causes the data to have a greater spread or variation. Now, which was affected more? The original mean and standard deviation were affected, I think that should be affected, isn't it? Anyway, more greatly by the inclusion of the outlier of 15. The mean decreased by 3.29, where the median decreased by only 0.5. The standard deviation increased by 9.89, whereas the IQR only increased by 1. This makes sense because the median and IQR are resistant to the effect of outliers, where the mean and standard deviation are not, which is why we use median and IQR when we have skewed data or we have outliers. When the data is reasonably symmetric, it's more appropriate to use mean and standard deviation. Okay, referring back to the original 20 scores, the distribution was reasonably symmetric, but not exactly symmetric. It is slightly skewed. Note, though, this skewness was not nearly enough to prevent us from using mean and standard deviation to describe the data. Use the mean and median to justify this slight skewness. In which direction is it skewed? The mean is 84. The median is 84.5. If you have a perfectly symmetric distribution, those two numbers would be the same. If it was perfectly symmetric, the mean would equal the median. Those two measures are very close, but not exact. The mean is slightly less than the median. This is an indicator that the data is typically skewed left. Now, with only those two summary statistics, you don't have a lot of confidence that it is slightly skewed to the left. It's an indicator that it is. Typically, that's what you expect. So when you make this statement right here, you don't want to say because the mean is less than the median, it is skewed left. It is an indicator that it typically is. You don't want to say things in absolutes if they're not absolutes. Okay, referring back to the original 20 scores, the distribution was reasonably symmetric, but not exactly symmetric. It is slightly skewed, blah, blah, blah. This is the same thing we clarified at the beginning of the last slide. Use the Q1, median, and Q3 to justify this slight skewness. All right, this is something different that I don't think we've talked about in class. It may have been addressed in a textbook. I forget exactly where. So the Q1 is 80. The median is 84.5. Q3 is 88.5. We already ran those numbers from a while ago. The distance from the median to the lower quartile is 4.5. The distance from the median to the upper quartile is 4. Because the distance from the median to the lower quartile is slightly larger, that's an indicator that the data is typically skewed left. So again, with this wording, if the only thing you have is that information, there's not 100% guarantee that it's going to be skewed left. It's just typically that's what you would expect. When it comes to box plots, also something that's very often used if one whisker is significantly longer than the other one. If that whisker like extended way over here, that would be typically an indicator that the data is skewed to the left. If that whisker was extending way over here, that would typically indicate that it's skewed right. There's no guarantee with that. Box plots don't give you all the information. It's just that's what you would typically expect when looking at a box plot. And that wraps it up for today's lesson. And where is the stop button for Loom here? There we go.